what we try to do is, as we realize that we can use star as part of a declarative statement, I think what we should attempt to do is to write some small fragment of code and try to work out the meaning of this star. So what you could do, perhaps we start off with one, let's say, int I semicolon. So we have one simple declarative statement, always one int box to play around with, which of course is going to provide or generate a symbol table entry. Is of course I can go back to our earlier style of the symbol table because that is sufficient for the moment. We can go back and say it contains of 2000. We'll just do that. But go back to the earlier style, not what we did during the linking. See, only for linking purposes I discussed the full-blown symbol table. Now the earlier style is a very convenient way of writing. You don't have to say defined, undefined, available, not available, exported, imported. All that nonsense is not required for understanding the compilation process. So we'll go back and write the earlier style of symbol table entry. So we have one symbol table, symbol entry, I. Now we'll declare one more fellow. Now since people said that I could use the star as part of declarative statement, we'll just say int star p semicolon, whatever it means. I don't know what it means right now at this point of time. I only know that star can be used as part of declarative statements because we know that, and it is a prefix operator, so it has got to be before the p. You can't say star p, int p star has no meaning, or star int p has no meaning. It should be int star p because it's a unary prefix operator. It should always precede one symbolic reference. So therefore, without really knowing the meaning, we'll go ahead and write the declarative statement of p. Now, of course, I was a fellow, we have this covering rule, right? Covering rule says very simple, is whatever you cover is going to behave exactly like what is not covered. That is why I behaved like integer, correct? So same way, now we have another symbolic reference called p. Now what does this p behave like? P, you just cover p in the declarative statement for p. That looks very straightforward. When you cover p, actually you're going to get a vague looking fellow called int star. I don't know what is int star, we don't know what it means, but anyway, it behaves like int star, whatever that means. We'll try to derive what is the meaning of int star shortly later on. But whatever int star means, p is going to behave like an int star. Because that is what, when you cover p, that is what you get. And it's going to be, of course, contents of 2002 because we have still assumed the int is a 2-byte size value. So I was a 2-byte box. So p is the fellow which behaves like int star. Don't even ask me for the size of. I don't even know what kind of an animal this p is. So don't ask me how many bytes of. We don't know yet because all we know is p behaves like int star. Now we can make a couple of observations. I think on this is very straightforward. Observation A, if you want, I'll make one observation A. I behaves like int. I think that is very simple because this is the covering rule. Actually, we just use the covering rule itself to understand the meaning of a lot of these declarative statements. Without covering rule, it's very difficult to understand. What you're covering is you're covering part of the declarative statement, and what is covered is going to behave exactly like what is not covered. That's a very simple rule. Now, that is a known stuff. P also we said P behaves like int star, whatever that means. We know what is an int, the 2's complement integer, but we don't know the meaning of int star. It's a new kind of a data, new kind of an animal, but whatever that animal is, it behaves like that animal, right? We don't know. I'll do one more thing. See, why don't we cover this part of this? Okay. So I just covered the star p part of this declarative statement. Now this actually, can you make out the difference between this and this? Int something semicolon was there, so you said something behaved like int. Now when I cover it like this, what are you going to say? The same thing, right? Int something semicolon, that's what it looks like. Is therefore, what does star p behave like? Star p behaves like? Just like I, actually there's no difference between the star p and I. In fact, since it behaves like int, you can use star p wherever you can use an integer. For example, I'll just write a couple of statements. I don't know the meaning right now. Star p equals I semicolon is alright. It's perfectly fine. If fellow behaves like int, this fellow behaves like int. So you can write that, no? Or you can say, for example, I equals star p semicolon is also valid. I want to multiply a couple of integers and store it into I, no? Nothing wrong with this. Star p semicolon, you can store that into I. These are all perfectly valid statement. Whatever they mean, we still don't know what the meaning of that, but they are valid. Now coming back here, star we know is the contents of operator. Don't forget, when it says star p, it is not the multiply p. It is the contents of p, correct? So therefore, when you just expand the star, what is this contents of p behaves like? Int, no? I'll give an analogy, analogical statement. Analogical statement is like this. Contents of 1006 10th main Basaveshwaragar is MLS Shastri. Okay. In fact, you go to this Rajajinagar 10th main, go to the address 1006, a house. That's an address actually. You go there, you take contents of that, who's sitting inside that house as a box. You will find MLA Shastri sitting there, right? Not now, after some time. So what is this 1006 10th main, Rajajinagar? What is it? It's my address. So if contents of something is a kind of data, that something must be the address of the data. No question from me. It's like saying contents of 2000 is I, You got that here. What is contents of 2000? Is I. Therefore, what is 2000? Tell me what is 2000? Is address of I. So 2000 is really address of I. Correct? Or there is another way of writing. 2000 is ampersand I. The ampersand as a unary prefix operator, which is the address of operator. So ampersand I is 2000. Ampersand I is address of I. Address of I is 2000 because I is contents of 2000. So 2000 must be the address of I.